In this nugget, we will be looking at strong and weak acids. In aqueous solutions, acids produce hydrogen ions. For example, hydrochloric acid has the formula HCl. The H represents the hydrogen, which becomes a hydrogen ion in aqueous solutions. Hydrochloric acid is a strong acid, so the molecule completely dissociates in water, forming hydrogen and chloride ions. In aqueous solutions, strong acids fully dissociate or ionize into ions. For example, 3 common laboratory acids used regularly for science experiments are hydrochloric acid, nitric acid, and sulfuric acid. These are examples of strong acids, and when placed into water, they fully dissociate or ionize. As a result, there is always a high concentration of hydrogen ions in solution. In aqueous solutions, weak acids will only partially dissociate or ionize into ions. This is also reversible, as shown by the reversible arrow symbol, which means there are less hydrogen ions in solution at any one time compared to a fully dissociated strong acid, and an equilibrium is achieved. For example, ethanoic acid, which you might know better as vinegar. This is a weak acid. It only partially dissociates or ionizes in water, so only a few of the hydrogen ions are free in solution. Less hydrogen ions means a higher pH value and therefore less acidic. The concentration of hydrogen ions in aqueous solutions determines the pH. The greater the number of hydrogen ions in solution, the more acidic a substance is, and the lower the pH will be. The beaker on the left has a greater concentration of hydrogen ions compared with the one on the right, so it therefore has a lower pH value. It is more acidic because it contains more acid particles. This is because the beaker on the left contains a strong acid, which has fully ionized or dissociated, whereas the one on the right is a weak acid and has only partially ionized or dissociated. You can tell the difference between a strong and weak acid by doing a simple experiment. A metal carbonate or a piece of magnesium is added to both acids of the same concentration. Whichever produces the most gas in a given time is the stronger acid. This is because the stronger acid has a higher concentration of hydrogen ions. To summarize, the pH of a solution is a measure of the hydrogen ion concentration of an aqueous solution. A strong acid fully dissociates or ionizes into its constituent ions. A weak acid partially dissociates or ionizes into its constituent ions. This reaction is reversible and an equilibrium is achieved. A simple experiment can determine which of the two solutions is the stronger or weaker acid. Keywords: equilibrium, the point in a reversible chemical reaction where the forward and backward reaction rates are equal. pH scale, a scale to show how acidic, alkaline, or neutral a solution is. Aqueous solution, a mixture containing a solute dissolved in water. Reversible, a reaction that can go both forwards and backwards. Dissociate or ionize, the breaking apart of a molecule into its constituent ions.